It takes weeks to erect a high-rise scaffolding system, mapping thousands of steel components into a rigid grid. But it takes less than 3 seconds for that entire steel grid to completely collapse into the street. A collapsing steel grid follows a specific sequence of mechanical stress. Understanding why these structures fail requires looking at the engineering limits that are breached long before the first bolt snaps. The geometry keeping these towers standing is strictly governed by a federal code, OSHA 29 CFR 1926 Subpart L. Yet, year after year, scaffolding violations rank consistently among the Department of Labor's top 10 most cited safety failures across the United States. To understand why a structure designed to hold immense weight suddenly folds, we have to perform a spatial autopsy. We need to dissect the anatomy of the framework from the dirt straight up to the sky. Gravity demands that the entire weight of the structure, plus the workers and their materials, travels down the vertical legs into the ground. OSHA Rule 1926.51 requires that every scaffold rest on an adequate, firm foundation. This diagram illustrates safe load management. A metal base plate connects to a wide wooden mudsill, spreading downward force evenly across the soil. But substitute that mudsill with scrap wood, and physics break down. The leg sinks and the entire vertical column tilts. A fraction of an inch of settling at the base multiplies exponentially as you move up the tower. Any structural compromise at the foundation instantly fractures the integrity of the levels above it. As you move higher up the scaffold, gravity is no longer the only enemy. The structure has to withstand lateral forces, like the constant push of high winds or the shifting weight of a crew in motion. Builders follow the OSHA 4-to-1 rule. A 5-foot base safely supports 20 vertical feet. Above that red zone, it must be tied into the wall. Without ties, it becomes a freestanding lever. A single lateral force causes it to pivot and tip. To combat internal sway, builders installed diagonal cross-bracing. This locks the right angles in place, keeping the vertical legs plumb and transferring wind resistance safely through the grid. But weather introduces unpredictable variables. Mandatory safety netting designed to catch falling debris creates what engineers call the sail effect. The dense fabric catches heavy gusts, multiplying the lateral forces tearing at the steel. When builders ignore the 4-to-1 ratio and fail to secure tiebacks, they strip away the math keeping the structure upright. They are relying entirely on luck to keep the structure standing against the wind. We saw the result of that failed math in June 2019 at a 12-story construction site in Brooklyn, completely shrouded in dense green safety netting. Days prior, a subcontractor doing stucco work disconnected the scaffold's critical tiebacks to fill holes in the wall. The general contractor's superintendent explicitly warned the scaffolding foreman to dismantle the unsecured frame. That warning was ignored. On June 30th, forecasted high winds swept through the neighborhood. The gusts hit the netting, triggering a massive sail effect. The wind ripped the disconnected structure off the roof and sent it crashing into the crowded courtyard of an adjacent bar. A 32-year-old bystander was struck by the falling debris, suffering permanent brain damage. The Brooklyn district attorney treated the collapse not as an accident, but a crime. They indicted the foreman for criminal mischief and reckless endangerment. Beyond the geometry of the frame, the structure relies heavily on how the crew navigates the access points. Under federal code, workers are strictly prohibited from climbing the diagonal cross braces. Doing so applies localized stress to components designed exclusively for structural bracing, while drastically increasing the risk of a slip. The moment a worker steps onto a platform more than 10 feet above a lower level, OSHA mandates the immediate use of a personal fall arrest system or a fully installed guardrail network. The decking they walk on is equally regulated. Planks must overlap their supports by at least 6 inches, and the platform must be fully decked, leaving no gaps wider than 1 inch. When crews bypass dedicated ladders or leave gaps in the planking, they create a severe hazard for themselves. Even worse, they turn the ground below into a lethal fall zone for civilians. To prevent these compounding errors, OSHA requires every site to have a designated competent person. This individual is legally required to inspect the scaffolding for visible defects before every single shift. They are hunting for specific, often invisible flaws that workers naturally normalize over time: a missing locking pin, a base plate that shifted overnight, or a removed wall tieback. The physics demand 3 physical realities. Foundations must distribute the load, towers must respect the 4-to-1 ratio, and platforms must be fully decked and guarded. Structural integrity is a dynamic state, requiring constant technical verification to stay intact. Keeping a crew alive depends on the daily discipline of oversight that catches a flaw before the wind can exploit it.